we added the third chair because Japan was, yeah, I think Aisha added my mistake. Okay, technically it's still on the chair. Yeah, that's true.
Up to you. I didn't know if you had made a change in chairs and not told me.
No, I did not change it. It was not absent completely for this one.
Sure.
Yeah.
It's fine with me if you want to.
No, I think
it's
it's not.
If he wants to continue.
So he was absent for almost 1 year or 1.5 years. That's when Suresh added Sadhu. So that's the thing actually. So he hasn't sent anything, any mail or anything over the last 2 years.
He's okay.
He's okay. He's busy with other things. But you're right. I think this maybe because he's officially still listed. I should have my mistake. I'll edit after this meeting. I'll edit.
He wants to stay on. That's fine too. He wants to. Whatever you guys want to do. It's fine with me. We'll all agree.
I didn't think about this actually. I didn't think I just blindly because we are active. But it's a mistake now. Just legally corrected. Okay, now we get started. Hello, everyone. Thanks for joining. Welcome to the DMM working group. I'm Sri Vindavalli, and Satoru-san is joining remotely. Hey, Satoru-san, you say hello. Can you say hello to everyone? The audio is on. Can you hear us? Satoru-san? So anyone remotely, can they confirm the audio is coming out okay? Okay, okay, cool. Thank you. All right. Welcome to the DMM working group. I'm Sri Vindavalli, joining remotely. First thing, following is the IPR statement. Please be familiar with the IETF IPR guidelines. And this is the Note 12 statement. Please be familiar with this the IETF Note 12 statement. please understand the implications of what you say and the legal interpretation of legal implication of that. And blue sheets and note taker. Anybody willing to take notes? Thank you. Carlos, thank you. And a quick update on the working group documents. We have the following documents in the working group pipeline. The first thing is the segment routing for IPv6 for mobile user plane. This is it completed the working group last call, and we have forwarded it to our area director for ESG. Eric, do you want to comment on this?
Sure. It's just waiting on me for getting a chance to do AD eval. I did have some useful conversations with people in the last couple of days here, so it's great to be back in person and get good high bandwidth communications for some things. So I don't anticipate any difficulties. Just my own time scheduling.
Okay.
Sorry about that.
So the ball is completely in your court, Eric. So yeah, please let us know if you need something. Yeah.
Yep.
Okay, thank you. Next is the mobility aware transport network slicing. We have a presentation today, right? John, you're going to provide a status on that?
Yes, I can provide a status on that. We're at version 4 now.
Okay.
And I'll provide an update with
Thank you.
what's happening. Thanks.
And the third one is the user plane protocol and architecture analysis. There hasn't been any updates on this. I think, yeah, we need to discuss with the authors on the, where we are with respect to on this document. It has expired. Next is the computer submissions. One is, from myself. This is the first one. And the other is from Carlos, mobility challenges in virtualization environments. So there's some time allocated for both the presentations. That our first presentation today is on the working group status on mobility aware transport network slicing from John. And we'll start with that, followed by these are the other presentations in the queue. And so first thing, John.
Thanks, Sri. Do I control it? Or?
Yes.
Oh,
yes.
okay.
Yeah, I think it's okay. Maybe sorry.
I'm fine if you control it.
Yeah.
Also, there's only a few slides, so.
Let me share the slides actually.
Yeah. Okay. I can be pretty loud, so I'll stay close to the mic. So this is the mobility aware transport network slicing for 5G. It's version 4 of the draft. The changes, if you go to the next slide, please. Yeah. The updates from 03 to 04 are not significant. I mean, they're basically to update the information on the slices draft and some other miscellaneous editorial changes. So we think that a lot of the things that there were comments on, we've addressed, and it's somewhat ready to progress, I think. So, but there were questions about how it relates to the T slicing, and that's what we're trying to address as authors. So if you, on the next few slides, I'll address how it relates to the base slicing draft. I'm sorry for the formatting, but there's a number of things. I mean, that we've referred to the draft as well in T's, and the statements like the connectivity and resource commitment is exactly what we also do in this draft. The other aspects that are I just copied a few of them here, that the slices could be one or more network technologies that's relevant to the draft here. the fact that it could span multiple technologies and multiple administrative domains, I think that's clearly one of the use cases that we consider. And also the fact that, the attachment circuit in between the customer edge and the provider edge, the fact that it could be part of the provider or independent of the provider. Those concepts I'll relate to in the next couple of slides with the 3 use cases that we have. Next slide, please. Okay. So I guess, this is using terminology from the T's. So the service demarcation points. So there are 2 cases that we're looking at here. Case A is when the CE and the PE are perhaps in the same node. And I'm referring to the T's draft as well. So this is one of the use cases where the transport resources can be managed from within the same device. So that's one use case that we identify. The second one is where they're in the same layer 2 domain and they can be connected via VLAN. That's a very common use case, especially when it's connecting multiple components in the RAN, especially. So I put them as this similar. These 2 are somewhat similar in the way that the problem is approached or solved. And just pointing out in that figure, this is an old figure from before, but you can see that the 3GPP logic interface IDs refer to VLAN, MPLS segment routing. And UDP port is not there, but it comes on the next use case for us. Please. Next slide, please, Ray.
Okay. So one question, John.
Sure.
Is the CE part of the UPF or the CE is a separate entity here?
Um,
part of
So the entities, the question is the CE part of the UPF. In this scenario, the UP, we call it the UPNF, which refers to either it's a user plane network function, and the user plane network function may be a Gnode B or a UPF, and that's the customer edge in this case. And the provider edge is the transport router edge that provides the slice in between the 2 provider edges. And yeah, I'm sorry I didn't explain in too much detail, and thanks for the question, actually. So in this case, the third case, the user plane network function and the provider edge are separated by a layer 3 network. And in this case, the draft also talks about a solution where the slice identifier can be transported to be identified by the PE router. So if we take these 3 drafts, as far as we've seen, A and B are, they have some other drafts. I haven't followed T's in much detail, but there are a couple of drafts in T's that talk about A and B, but I haven't seen one that talks about C, this use case where the CE and this UPNF and the PE are separated by a layer 3 network. So we do cover these 3 cases, and going to the next page, I think that's all we have really. So what I think we need to do now is to share it with other working groups. To that effort, I'm glad that this is a meeting where I could talk to a couple of the T's authors. I'm planning to, offline, obviously, I'm talking to a couple of those authors to make sure that this is in line with what's in the working group, working group draft, as well as what they're planning. And then I guess we'd like to get detailed reviews from this group and also other groups.
Thank you, John. So one key feedback I think last time we gave was to run this work with the T's working group to make sure they're aligned with this. Particularly, there's some work happening there, right? We just want to make sure there's no overlap or somehow it has to complement each other, right? I think so. That's one thing, right? Yeah.
Yeah, I completely agree, Sri. I think that's exactly what we need to do. To that point, I'll be talking offline with the key authors, at least two of the authors that are here on Wednesday, and we'll make sure that what's proposed here aligns and also is complementing, because we don't want to duplicate and confuse people who are going to be reading these drafts later. So I'll definitely make that an effort and make sure that these are complementing and also accurate.
Okay. I think that my second comment is on the working group feedback. And can you summarize, John, like any key open issues that you're tracking or what came out of the working discussions? There have been some threads, but
So
can you
on,
summarize?
on the working group discussions, there were, it's been a while now, so I'll have to refer back to see some of the claims. But I think many of the questions were around, the T's and, how this relates, the slicing aspect of it and how it relates to the 3GPP domain and all of those, those were but uh, there weren't any major technical changes, but it needed to be, what we needed to do was revise the draft to make sure that those aspects, like, one was a confusion as to whether we are redefining the 3GPP architecture, which we're not. Things like that, So that was one of the most major comments, but other comments were about how it relates to T's. And we've addressed all of those. But I think the T's, to that point, the T's draft is evolving all the time. And, because it's not an RFC yet. So we're going to work with the T's folks to make sure, maybe in a couple of weeks, I'll put another revision out, which fully takes care of the T's development. I think it's stable enough now. So I think that'll be addressed. And I think we'd like to get some reviews from that point too.
So now
Make
any
progress.
questions, comments from?
Tinji from China Mobile. Regarding the UPF, actually you're calling it the UPNF function. And then you mentioned that could be a GNOB or UPF.
Um,
Well, okay.
just to clarify, it's we've just put a general term UPNF. Just to clarify that from the point of view of slicing, those are two endpoints, user plane network functions. So we're not using a 3GPP terminology there. So in this draft, we're calling it a user plane network function, so UPNF.
Yeah, well, I try to map with the 3GPP function here, because for NR slicing is important. So for the RAM part, well, forget it. But for the NR core slicing from the backhaul up to the core network, you are going to deal with the backhaul slicing and also the NR core slicing. So here, well, I'm looking at your thing. Suppose you're going to do the slicing from the GNOB side. And then how are you going to map, from the GNOB to UPF and then beyond the UPF to like N6? So basically you have the backhaul slicing and also NR core slicing. Thank you.
So I think there were three parts in there. One is how to do from the backhaul in the RAN, how to do the slicing in the core, and then the N6. I'll start with the N6. We're not doing anything there because that's outside of that would be a general slice in my opinion. So on the core side, what's happening is that there are the two transport endpoints. Sri, if you could just move back a couple of slides. Oh, that's good. So, yeah. Yeah, I think this is good. And then that's good. The other one is good. Yeah, yeah, I guess these figures don't show, but essentially there's a transport endpoint, the 3GPP transport endpoint. You can see on the figure on the left from 28541. There are two transport endpoints in the UPNFs, whether it's a G-Node B or a UPF. Those transport endpoints could be VLAN, MPLS, segment routes, and we're proposing also UDP ports, which are not in the 3GPP standard at this point. So what happens is the slice is defined between those endpoints. If it's a VLAN, then that's what would be used between on the radio, for example, most likely, because it's not based on a per user, I mean per UE. The user is really the network provider in that sense. But when it comes to the core slice, you identify each user's flow. And that user's flow is configured by a profile. I mean, that's a 3GPP endpoint. I mean, 3GPP logic. And that's mapped to a transport endpoint, which is carried in UDP. So the UDP port, this is described in detail in the draft. So based on that, when you look at the IP address and that specific UDP information, the PE can map it to a slice that's already been configured. So that's the process.
So John, one comment I have is, I think, when you say 3GPP design, define it, we define it, I have a problem there. I think we have to be super careful there. Particularly from SRv6, we're getting a lot of pushback. So my understanding was we are mapping traffic on the transport plane. Transport plane is today set up in an independent manner. 3GPP doesn't deal with it.
Right.
Here we are only saying how to map traffic on if the transport network supports a set of slices or some separation, right? Somehow how we map the traffic here. That is the scope, right? So I just want to make sure we don't go even one.
No, yeah, I'll clarify that. I mean, the question was more like, if I understand it right, just I'm trying to paraphrase and see if I understand that. So on the 3GPP side, we don't make any changes.
Yeah.
That's, if you look at those are the transport endpoints there, the transport, EP transport. Those are the endpoints in 3GPP. So the management and configuration of that transport network itself is not in the scope of this work. So that's done. I mean, there are already standards. I mean, there's 28541. There's work in T's on ACTN to configure the slice itself.
Yeah.
And then the other part is in terms of signaling for the user. So for example, if there's a UE1 and a UE2, I mean, a PDU session has a certain resource requirement. So that resource requirement is mapped to, the endpoint, the transport endpoint. So there may be multiple transport endpoints corresponding to the resource capability that has been reserved. So it's only that mapping that we're talking about.
So I think it's good to discuss this on the mailer.
And, yeah, sure.
I think, let's make sure there's no confusion here. Quick follow-up. Yeah.
Yes, follow-up question here. Can you mention about the resource mapping? I think in the 3GPP, when a UE start to ask for some slicing, it's going to use two important parameters. One is the DN, the other one is the NSSAI. So when a UE start to ask at that moment, has your slicing structure been determined already? Or it's just like dynamically based on, it's like a UE demand or UE oriented and based on something, and then you start to do your slicing allocation.
Right. So when again, we're not changing any of the 3GPP signaling. So the PDU signaling, the signaling to set up the PDU that includes the SNSSAI and other parameters act as they already are today. So, and based on that, there's also the management part in 3GPP that allocates these endpoints that correspond to resources. I mean, that may be related to SNSSAI or other parameters in the signaling. So what we do is only to say that we are mapping that information to the transport endpoint. So for example, there is no change in 3GPP. The only problem is that 3GPP doesn't define how to map it to the transport endpoint. I mean, right now it goes as far as these IDs. So in the case of the UDP port, we define more details on the mapping. Does that clarify?
Yeah, it's clarified. But the only thing is the last question from my side is Doing the mapping here, still you said you're not going to change anything on the 3GPP side, but the mapping there, you have to find some way to associate 3GPP slicing with your slicing. So it seems to me you have to ask 3GPP to do something in order to get to you, right?
Okay, so the 3GPP slice is really talking about the users, the 3GPP user. In this case, it's the slice, or the provider and the customer is a 3GPP network, not the user. So it's only this mapping between the 3GPP provider and the transport network provider that's managed here.
TNG, if like if it makes, and this is Krishnan, so if it makes it simpler, right? So the AMF to NSSF signaling will happen. You'll still end up with the same NSSAI, but it's just like something that's totally underneath it, right? Like it's, if that helps you like understand. So there's nothing in the 3GPP messaging or structures that is getting changed here. It's just the underlying, think of it as like configuring the underlying network for how the NSSAI gets mapped to transport resources.
Yeah, we shouldn't be requiring anything from touching that interface here.
Right.
So, any other questions? Thank you, John. So
Thank you.
Let's discuss this more. So next is I think for the draft, which is so I'll be presenting this. This is my chair hat off as an author. So this is a new document, draft cryptographically generated device identifiers. Just to set the problem statement. So if you look at the NAI, IETF has defined the NAI. NAI is the network access identifier. It's used in identifying the subscriber or the user attached to an access network, right? So if you look at there are many of the use cases where we need the identity of the device, not the identity of the user. For example, I may have my MacBook and a laptop, and I may be attached to the network. But in both the cases, the identity that I'm using is still my Shri as the identifier, the username, right? The NAI is Shri@cisco.com. But what we need is a device identifier for the various use cases where we need the device identity. That's the overall context. Now the question is, currently there's no standardized or a format for a device identifier. I think what I'm trying to see is like, how do we define a format, an identifier, some semantics around carrying a device identity. That's the overall the motivation. Now, if you look at it today, on any endpoint or a device, if you look at a mobile device with this wireless Wi-Fi, Ethernet, and cellular NIC cards, the identifiers that are present are there's an IEEE 48-bit MAC address. There's a username NAI which is used for access authentication. There's also at the device level, there's a serial number. It's like, but there's no consistent way. I think, different vendors use it different things, but there's no standardized format for that. Then if there's a certificate that's burnt on the device, then there's a certificate ID or some parameters that can identify the device as well. Then on the cellular interface side, there's IMEI, there's a PI. Again, that's one thing. There's also the IMSI and the equivalent SUP in the 5G system. Now, these are the identifiers that are present in today. I think, but some of the things I think we need to be sensitive to the GDPR regulations. One thing, if you look at the RCM with the MAC rotation, there's no stable identifier today on the endpoint. The 48-bit MAC address is gone. I think a device will not use today for the probes. Apple devices are changing the MAC, but in a year from now, there is most likely the MAC address will be changing, right? I think there won't be a stable identifier that the MAC will be presenting to the network. So we can take this out. Now, if you look at the other identifiers, we have the same issue, right? I think for the GDPR, if I'm attaching to one network, one access network, let's say IETF network, if I expose my identifier, then I go to another network, and if I expose the same identifier, somebody can be able to track me. So the question is, these identifiers, we won't be able to use it because of the GDPR or other regulations. I think that's a general issue here.
Yeah, Carlos Bernardo, UC3M. Regarding the MAC point, I agree on the point that there is rotation and everything, but the devices still have one globally unique identifier that they could use for this. I'm not saying that they should, because I also see the GDPR issues, but the point is that even if they randomize for everything, there will be still one globally unique identifier, because so far today you can even configure not to randomize, not to rotate, and use that globally unique identifier that is present on the device.
No, absolutely. Thanks, Carlos. Agree with that. But the question is, I think, where I'm getting to is, even if there's a stable, fixed physical MAC address from which other MAC addresses are generated, but that address cannot be presented. I think that's where I'm coming from. Right? Now, if you look at it, I think further, just going further, some use cases. I think simple use case, I have two devices, right? Now, my login identity is the same, right? I think the question is here we require, two different identities, let's say. So the network can apply device-specific policies. If you want to apply a subscriber ID, if you want the policies to be bound to a user identity, sure, you can do that. Shri@cisco.com, that's sufficient. But if you want some level of maybe rate limiting or something, where you say that, yeah, I don't give more than certain amount of bandwidth on a device basis, we need some device level, identification. The network should be able to say, yeah, this is, in both our Shri's devices, but this is device MAC1, this is some other device. So some device level identity. Now, if you take an environment where you have private 5G and Wi-Fi, now there are various use cases where private 5G does not mean that the device is using a SIM identity. Now, if you look at the CBRS specifications and all of that, they support for ETLS, ETTLS. So what it means is, in some cases, a user may be able to use the exact same enterprise identity for both Wi-Fi and cellular. So that means my earlier example, my user ID in both the racks, radio access technologies, is the same. Now we need some disaggregation where I can identify the device. So I need the device level identity. Now, if you go to another example, if you took it like open roaming environment, open roaming is what WBA and WFA standardized on. If you look at the open roaming, there's something called RCOI, routing consortium ID, right? The number of in the federation, there are access network providers, there are identity providers. Now I can go to any access network, and if that access network supports that RCOI, I'll be able to use the identity. Now the point I'm getting to here is, I'll attach to different access networks. Now for mobility and for other reasons, what device identity should I expose to this access provider? My IDP, if I'm using the same identity, my identity may be the same, but my point I'm getting to is, will I expose the same IMEI, or should the IMEI be something unique, right? So given all of this, I think, where, the requirement is like, what can we come out with a structure semantics where a construct where device identity is dynamically generated, and it has some relationship to the access network, meaning, my identity that I'm exposed to IETF network is different from the device identity that I exposed to, let's say, Cisco network or to Starbucks network. So the identity can be generated cryptographically and somehow keep a relationship only to a given network. I think that's the motivation here, right? So two things, right? The identifiers, method, binds the given access net, binds the identity to a given access network. Device will have a unique identifier for each access network, unique to the device. If I have two devices, I'll have two different identities. And if I'm attaching to two different networks, I'll have two different, obviously different identifiers, immutable within that network, right? I think that's one thing, and is access agnostic and can be signaled over any of the radio access technology. So meaning, I attach to IETF.org, I am attached to a cellular radio and Wi-Fi radio. Somehow, if I expose the same device identifier, and if there's a way for the network, there's a way for the endpoint to assert that I own the identity. See, the assertion part is missing. If you go back to earlier, if people can say, let's say we use IMEI, it's unique, or MAC address, which is unique, but there is no semantics to assert. In other words, I can, if I know Eric's, IMEI or device ID, I can signal it, and the network is not able to validate it. So here, but if we generate device identities based on cryptographic in a manner and a fashion, then If I hold this corresponding private key as something, if need be, network will be able to, I'll be able to prove it to the network that I own that identity, device identifier. I think that is where, so if you look at the, maybe in one implementation, one method is like, the device owns public private key. Maybe it's provisioned as part of the device onboarding, the access network gives those keys, whatever, right? And there's an access network identifier, and there's some other auxiliary parameters based on some login or something. Using all of this, I generate a cryptographically generated CGDI. This now CGDI is unique to the device, unique to that network. If I change my device or if I change the access network, my CGDI changes. So now this also gives the network to allow the user to prove that he's the owner, right? It helps in various use cases. Now I think identifier generation, again, as explained, I think we can tie it with some other things like SSID or 3GPP, MNC, MCC, whatever, the archive. We are based on this, we can tie it to that, and based based on this, we can generate, if we can define it. Once the identity is generated, it will be signaled over 3GPP or whatever interfaces, whatever maybe the access methods are. And subsequently, I think the validation is, I think as I explained earlier, it allows the network to validate and periodically rotate, right? I think we'll have a structure in place. I think it will solve a number of use cases, particularly mobility scenarios. That's what, yeah.
Carlos Bernardo, UC3 again. So one clarifying question. I don't remember exactly the details, but have you checked how this relates to what Sen did in the past and also with the cryptographically generated interface identifiers for IPv6 addresses? Because that seems to remind me a bit about that, but I don't remember the details, so I may be completely wrong.
Yeah, I'm familiar with SEND. See, SEND is allowing me to prove to the network that I'm the owner of the IP address, right? Here, I'm not talking about the transport endpoint, but I'm talking about the identity of the device. So SEND is a ND thing, right? Here, you're not binding to any protocol, but it can be signaled over any of the protocols, right? Like how IETF has defined now, I'm arguing that you have to define a device identity in a particular manner which SDOs will adopt.
And regarding the cryptographically generated interface identifier, because I think there was some spec that define how to generate that with the public key, also with the prefix, so that identifier mutates when you change access network. So that seems to be a bit similar. I don't know if you checked that. I don't remember the RC. I don't remember. I can take a look and send you offline the RC, but I think there is one that.
I looked at, I'm familiar with some of the earlier work on this SAPI, or I don't know which one. They did host identity, the HIP guys or something did similar things in the, right? But nothing, I've not seen anything on device identity.
Okay, I mean, I think that there was a document with Fernando Gont and a few folks on the specifically for interface identifier for IPv6 address generation.
I think SAVI or something, I vaguely remember it was 2013, 2014 timeframe, but not along this. Thank you. Any other questions, comments?
Actually, not related to this slide per se. This is John from FutureWay. But generally, do you see this being applied to cases where, like in 3GPP, where you have ATSSS and a multipath, I mean, with two radios, the Wi-Fi and a 3GPP radio?
I think 3GPP will be happy using IMEI. Probably, I do not know what concerns they have around privacy, right? That is one thing, but I think I think there are a few things. I think where 3GPP has started with 4G, 5G architecture versus now. Now, like how you have SSID profile on a 5G device, you'll have a number of 5G profiles, right? So there, in that case, I have a trouble if somebody starts using IMEI in every access network, right? So IMEI is still used in 3GPP system, right? And as part of the access authentication, you signal that, right? Now, I do not know the implication of that, but I think even if you don't use ATSS, overall, my argument is there a device identifier that the client and the network can trust and it will meet the GDPR where it can be signaled without violating GDPR regulations.
Thanks.
Yeah, Alyssa Cooper, I was going to ask you something similar, or just picking up on that, which is, if that's the case, then, and you have, if there's any case where both of these identifiers get signaled, then you've destroyed the privacy properties of this one, because the IMEI is traceable.
Yeah, that's a good point, Alice. I think, obviously it has to be the CGDI in the draft. I put it in that IMEI can also be generated using the CGDI. In other words, even IMEI, if we don't use a physically burnt IMEI, if CGDI can give us a format, one of the output is an IMEI format, then we can then it will replace the 3GPP's IMEI potentially. The physical currently what is the currently used IMEI or the physically burnt.
I see. And that wouldn't create problems for the expectations about how the IMEI is used?
I think there's an impact on the stack, but I think the question is if the device supports this privacy capability, then they shouldn't be using a fixed IMEI, like how the industry has moved away from physical MAC to RCM. In the same way, they have to move to a virtual IMEI. It's a virtual IMEI, I'll call it.
Yes, I agree that that would be preferred if everybody who has to implement it is up for it. I guess that's really the question.
Yeah, I think somebody has to take the contribution to 3GPP and make this happen.
Yes.
I agree.
Yeah, exactly.
Okay. If there are no other questions in the chat or. All right. Next presentation. Next is Carlos.
The one that is
This first. This is what? So this is a new document.
yes.
Please explain on this.
Okay, I'm Carlos Bernardo from UC3M, and this is a new document that is preliminary kind of work trying to identify if these potential new use cases are, there is interest on trying to identify how IP mobility protocols could apply to these scenarios. Next slide, please. So the idea here is that mobility is no longer restricted to just a UE, a host, moving from one access network to another access network. That's the traditional use case, and we have been working in IETF for many, many years on this. But the thing is that today's deployments are moving towards virtualization. That's not new. And we may have services that are composed by different functions that are running in virtualized environments. So we have virtualized functions that are chained together, and we have a service function chain, BNF, forwarding graph, whatever terminology we use, but basically a service that is decomposed in different functions that are virtual now. So having that kind of overall scenario in mind, now we have different scenarios. So we have, of course, the traditional mobile terminal moving around in the access, fine. And that may have implications, even that traditional network, when we think of a service function chain where there are different functions, and there are also potential implications on how those services are instantiated depending on the mobility or depending on the location of the UE or the terminal. That's one thing. But moving to the more new potential scenarios, one is where we have a physical resource hosting a function that is part of the service function chain moving, and that may be the case very perfectly in potential future deployment scenarios where you may have devices hosting functions that are mobile themselves, or even if they are static, that they are wireless, and because of the wireless conditions of the environment, there may be changes in the topology of that service function chain. And the third potential scenario is in this SFC where we have different functions, even if the resources hosting those functions don't move or the topology doesn't change, we may have the need for migrating a function from one resource to the other for many reasons. So if you go to the next slide, let's try to see just each of these two examples, the one about the resource moving and the one about the function moving. So here in the picture, you have a terminal, a UE. There are two potential points of attachment, and then we have different resource nodes that are labeled SFC1, SFC2, SFC3, and in two of them we have functions that are composing a very simple service that will be BNF1 and BNF2. So in this environment, we may have the point that one of the nodes hosting the virtual network function, like SFC1 or SFC2, may be moving and changing the topology. So for example, before SFC1 was directly connected to SFC2, and because of the mobility now the connectivity is basically through SFC3. So in this scenario, we need to change something in the network to ensure that connectivity. So the question will be, one, is that scenario something meaningful today? And second, can we think of the use of IP mobility protocols, IP, PMIP, or mobile IP, or variations of those to support this scenario? What I call resource mobility, just to refer to resource moving around. And the next slide, please. The other scenario is this function migration. So we have the same diagram, and in this case, what we have is the virtual function BNF2 moving from SFC2 to SFC3. And again, the same question. In this scenario, do we think that first scenario is meaningful? I think this is meaningful, and there was some work in MBO3, if I remember properly. The idea is, can we reuse or extend mobility protocols to support this? And the main differences in these two scenarios compared to the traditional N-host or N-network mobility case is that here we have not only to basically, as the node moving or the function moving is not the end function of the communication, we need to ensure that the communication is maintained in more than one direction or with more than one node. So it's not only with the access network, it's not only the location of one single node, but it's the location regarding or within the topology of the service. So there are different things to do. The problem is slightly different. And the question, and we can go to the last slide, is well, there is interest in this type of scenarios and in exploring how IP mobility protocols could be used to address this problem. And one example problem and solution that is very specific, and is what I will present next, is already in that draft. That is the problem and the solution associated to that. But this is just an example. The idea of this draft is to document the problem and the potential gaps and kind of identify what could be done in DMM or in IETF to solve this problem. So any feedback that will be, of course, appreciated.
Thank you, Carlos. John?
John from Gateway. More or less a question for clarification. When you talk about the VNF2 moving from one point to another, it's representing a service, and I was wondering, would it not be possible to identify that service with an anycast address or something like that? That's one obvious, or not obvious, that's one way of solving that. The thing here is that the question I have to all of us is, will it be a good solution to try to address that problem from an IP mobility point of view? So you are moving the function and basically you try to, in addition to all the things that you need to do for function migration, then you try to make that change transparent to the other guys at transport or application level, and you manage that at the IP mobility level. Or maybe it's another kill and it's best to address that at application layer or with this type of anycast solutions. I mean, open question. I don't have the answer myself. Thanks. Or I don't have an opinion. Of course, I don't have the answer.
Wim Hendricks, Nokia. I think this ISO NVO3, as you mentioned before, I think has solved this already using IVX-LAN as a tunnel mechanism or Geneve, and then using EVPN as a control plane. So basically, you have the decoupling of the function from the transport. So as such, I think they have. There is a solution to this already within IETF that addresses this.
Okay, but one question I have, if I may, to the third case or to the second case, to the function migration or to the resource mobility? Because there are two different problems. Both of them?
Yeah, yes.
Okay. Because I thought that the function migration was the one tackled by MBO3, but I was not aware about the resource mobility. I would take a look then.
So the solutions that you have in mind, so this is a classic VM mobility across data centers, like east to west kind of scenario.
Yes.
So there.
This is for the third one, for the function migration.
Yeah.
Because for the resource mobility, it's a bit different because in a data center, the resources don't move. And here I'm thinking of, I don't know, if you have a service in a car platooning or a drone swarm, these kind of things where you may have the resource moving. So that's why I thought that the MBO3 didn't have a solution for this, because the scenario is a bit different than from the function migration.
So for where would you put the anchor in that case? If you want to anchor the traffic, where would you anchor it? Which side, east and west, where would you anchor the traffic?
For me, I mean, I don't have a solution in mind. Again, in the other draft, there is a specific solution. The thing is that you can notify the nodes that are indirect, or the next hops for the resource that is moving. You can notify them, okay, now you have to move the traffic to this particular node instead of to the other one, this type of things. So you can do tunneling, but tunneling between two nodes. I don't know. I mean, there are different approaches, but
I looked at it at that time, a few years back. The issue was where to anchor the traffic. Yeah, Eric.
Eric Klein, something that we did for function mobility in the data center in Google back around 2012 was use ILNP, which basically lets you do a 64-64 split. We use the ILNP data plane and the sort of in-kernel fixes to TCP to only checksum on the lower 64 bits, and then but we had to replace the control plane protocol because the ICMP based one we didn't want to use.
okay.
But
Yeah, I think the use case, if there is interest, generally publishing some info without defining new protocols, if you can say informationally, like, I think how existing idea of work can be used for solving this might be useful in my personal opinion. But I think based on what you're doing,
Okay.
yeah, follow-up question.
Yeah, at least from the 5G architecture point of view, have you ever thought about just to make your migration, the WNF migration equivalent to like the AF registration, those type of things to, you have WNF at one place, and then when it migrates to some other thing, it still has to go through like some registration function through some AF and talk about NRF, those type of things. So the control plane of the 5G has already set up the spec to handle this type of things. Have you ever, thought about something like it already?
No, I haven't thought of that, but I think that's, I mean, going back to the point of 3, I think it's maybe useful to try to document what can be done, what exists today to solve this type of problem.
Yeah,
that will be one way of addressing that.
Yeah, I think 3GPP document 23.501 is talk about this type of AF things already. So thank you.
I don't remember, but good, thanks.
Yeah, 23.501.
Yeah, Louis Jalil, I think I'd rather focus on the use cases what drives this, because I'm not sure if you look at different service providers. I mean, I work for Verizon, different service provider. I mean, there's regions, right? And you can't just move an IP to another region just because. So this is where they're. So I would focus on the use cases first, just to see, how valid they are, how much they are, and then we can. Because I can't see the use case, so I can't see the answers.
Okay, that's quite fair. And again, this document tried to focus on us answering that specific question. So there is no solution in mind. I mean, I have the other example I will present next, but that's for a very specific scenario. So I agree on trying to be more specific on the use cases. And of course, the use cases that I have in mind do not involve moving or changing between regions, of course. So it's not like impacting the global internet, it's something localized.
I think I think the use case, at least when I looked at it many years back, I think the use case were like, maintenance, or like, some, if you take my corporate environment, we have, tech support in different groups, right? Every 8 hours, there's another group that takes over, right? So their argument was you have to migrate a bunch of VMs there. I'm not saying those are the real this thing, but those are some of the examples.
But one point I want to highlight is that that's more on the function migration point of
Yeah.
but the resource mobility, I think that maybe, well, that's completely different from the point of view of use cases and the potentially part of the solution. Because if we think of a scenario where we have functions instantiated in one car and another car, and a third car is consuming the service, that is the composition of these two functions, and the car is moving and the topology around is moving, that is a bit different from the pure data center centric scenario.
All right, let's.
Yeah, in terms of the use case, I can China Mobile, TNG here. I can give you some real challenge we are facing. Is like it's like some NF network function, virtual network functions migration, well during like off peak and peak time, and then your mobile subscribers during some time will be located in one area, well, like weekdays. Well, for the weekend, they move to another place. So for those type of things, you have to go through some migration of the functions, or even if you scale up the number of functions or virtual functions that are going to support a type of service. So I do see the use case for your things in this scenario. Yeah.
Okay, thanks. So then we can move to the next one. The next one I will be very, very quick. It's a specific example that for an SFC kind of centric scenario. So this is just for the sake of showing something that we did, but please try to keep that decoupled from, I'm sorry. No, is this one. Yes, that one. So try to keep that decoupled from the previous presentation, because that was more on the generic problem. This is very specific solution. So we were in a project working on a scenario where we have SFC that is mobile, in the sense that the nodes that compose SFC are mobile, wireless. And we were looking into the problem of how do we ensure that in that environment we can react fast enough to changes, when typically in this type of SFC scenario, we have a centralized controller, and we wanted to kind of distribute that functionality within the network. So there is a set of companion documents to this one that deal more with this definition of what we call a pseudo controller, that basically is one of several nodes within the SFC that are monitoring what is happening, and based on several triggers, they can try to basically take over the control of the function, or part of the control of the function, to be able to react fast enough. So this kind of an overview of this pseudo controller thing compared to the centralized control in a SFC traditional environment, but applied to this mobile scenario. So in the figure, you have different nodes, UVs and a base station, and there this box, yellow box or green box, this tab, or orange box, depending on what you see, is a function. So you have here a scenario with two nodes forming a service, this one, sorry, and this one. And due to the mobility, you may need to migrate a function from one node to another. Okay, actually, it's a function composed of three functions. Service composed of three functions. Sorry, this one, and this one. So two on the UVs and in the base station, and then because of the mobility, we want to migrate the function that is running on the base station to another UV. And this is basically the case of the function migration that we saw before. Next slide, please. And to do so, we describe different signaling that could be used reusing mobile IP protocols. Again, I don't want to go into all the details, just an example. Basically, we define ways of updating a service function chain, so making reusing of mobile IP signaling to notify several nodes in the function. Okay, now the endpoint has moved to this other device, so please update the tunneling that you are using for the SFC to reach to the new location of the function. And if you go to the next slide, please. Again, I will not go into the details, but there is these messages that we define service path update to update the path that is used for the service function chaining, being able to notify the new IP address where a function is located. Next slide. Service path acknowledgement, basically to acknowledge that. And then we also have some mobility options. Go on, next one. To notify or to convey the identifier of the network service for the SFC. And the mobility options to carry also the function ID and the node ID where this resides. And I think that's all. Yeah. So this is just an example. I don't want to go into the details of one specific way of using MoIP for a specific problem with decentralized versus pseudo control in an SFC mobile environment where the nodes hosting the functions are mobile. But again, this is just an example. My main goal for this meeting was to get feedback that I got on the general mobility virtualization challenges, and basically I will try to work on that. And of course, I will welcome any input or any contributors to that draft documenting the use cases. Nothing on solutions. Let's go on the use cases, and then let's see if there is something remaining in the IETF that could be done on those use cases. Thanks.
Thank you, Carlos. Any questions?
Sorry, John. Carlos, is a question for clarification, actually. On the figure that you have multiple UEs, are you thinking of device-to-device kind of communication, or?
That's in scope, definitely. So there may be device-to-device or through the, yeah. So both are in the scope, yes.
Thanks.
Okay, thank you, Carlos. So we have one other last presentation. Is mobility challenges. Jeffrey, right? Jeffrey is going to. Jeffrey. Your turn, Jeff.
Yeah, they think of the other presentation first. Sorry? About transport IPv4.
Can you send one more?
Yeah. It's starting the original.
One second, sorry about that.
Okay.
Okay. You sent it to me last yesterday?
No, I sent it together when I sent it to the best working group a few days ago.
I think I saw it on the list when I went to DMM. It was on there.
Everything I received, actually.
Okay.
Because I'm pretty sure there was only one deck I received was this challenge,
Okay. Yeah. Maybe then I guess well, we can continue with this one first.
Okay.
Yeah. Yeah. Okay. So no problem. Yes. Actually, so before we go on to this one, about the topic of transporting VPN traffic payload owning, that presentation, which we don't have slides for now, I just made a presentation in the best working group. So once the recording is available, I will send a link to this working group because the use case is directly related to this working group.
But it's not a DMM working group, DMM document, correct?
It is not a DMM. It's not a DMM or document, but use case is directly related to this. So I will.
Let's discuss this. So we are now discussing.
Right.
This. Okay.
Right. So this topic also added at last minute. So after I found out we have extra time in this working group. So in fact, I didn't even get to discuss with my co-authors. Sorry about that. So next slide, please. I presented this idea in the last IETF meeting. Basically, in 5G, the UPFs are more and more distributed closer to the G node be the CU or the access node, and for the MEC purposes. And the CU and the UPF function, they could be co-located. And in that case, there is only a direct link in between, or even those two functions could be running on the same server. So now, what if in 6G, we actually integrate the two functions into a single function? I call it ANUP, A-N-U-P here. So with that, we get a flattened routing switching based architecture, where ANUP is basically a router and switch with wireless and wired connections, which is basically the foundation of the internet. Here, the 3GPP/wireless technologies will be responsible for wireless access, including mobility management, the UE authentication, authorization, all those things. And then leave the rest to the IETF/wireline technologies. That's the basic idea I presented last time. Next slide.
So just to make sure I understand, the GNOD and the UPF are co-located on the same box?
The co-location could happen in the 5G already, but in 6G, we want to take it one step further. They are no longer separate functions. They are just a single function. So that's the idea for 6G. Yeah. I want to have to say that if this idea makes sense and it gets traction, the work would actually be done in 3GPP. But we're discussing here just to first socialize this idea among people who are familiar with and friendly with IETF wireline technologies. If I bring this to 3GPP now, it will get killed on the spot, no problem, no question asking. So if we get enough support, especially from mobile operators, then we can bring this to 3GPP for the work. Yeah. Next slide.
Interesting idea. Okay.
Yeah. So we're still on the background here. So the advantage of doing this is that we get a simplified flattened architecture that is unified for both wireline and wireless. It would have simplified signaling, optimized data plane, and many 5G special features and procedures will no longer be needed or can be greatly simplified. For example, MEC, 5MBS, and LAN type services, and so on and so forth. Next slide. So there have been some discussions, thanks to John and Hanno on the mailing list. In particular, John raised some questions about advantages of integration and concerns of integration. And he also brought up some other aspects to consider. And I replied, and also as Hanno pitched in. And so I just want to take this opportunity here today, since we have extra time, to talk about, to have follow-up discussion on that, because now this for well-known reasons, it's not easy for us to have offline discussions. So I thought I'd just make use of this opportunity here. Basically a follow-up. So on the aspect of simplified signaling, in 5G, when the AN and UPF are separate, we need to use the N3 tunneling between those two functions. Even if they are co-located, we still have to use that. So in the upper right corner, I have a picture showing the AN, AMF, SMF, and UPF. We'll take 7 steps to establish that tunneling. But if we combine the AN and UPF into a single device, and correspondingly, we have a single control plane function in 6G, and then the signaling will be very much simplified. At least we do not need to worry about the tunnel setup. The CP control plane network function send the request to NUP, provide information, and NUP provide a response back. All that NUP needs to know is basically which data network this PDU session belongs to. That's the very basic information that it needs to know, besides the other things, right? So obviously.
So Jeffrey, I have one question here, right? So in your mind, when you say collocate or realize a single function, you are suppressing certain capability, right? For example, you said, yeah, N3 is not needed because they're on the same box. Isn't it a more an implementation aspect? Standards, even now you can do that today, right? You can collocate AMF plus SMF as a single function or put them on the same box. It can be done even today, right?
Right, that's what I'm trying to illustrate here. Today, yes, the separate AN and UPF function, you can put them into the same box, but still the signaling need to happen the same all the way in that upper right corner. So the SMF first to tell UPF, establish this PDU session. And so the UPF will allocate TEID for the tunnel, gets back to SMF. SMF needs to tell AMF. AMF will relay to the AM.
You can optimize the signal.
Right, that's signaling. And then data plane, today, even if you're on the same server, you need to have an internal connection between the two. And the GNOB need to put on a GDB header and then just to be taken off by the UPF. All those can be gone. And then we do not need the in-cab and decab. You get a better throughput and the performance. And yes, indeed, if the implementation today is clever enough, you can figure out that, oh, even though I'm getting separate signaling for the two functions, I will realize that they were on the same server. Therefore, I'm going to bypass the GDB process. You can do that as well, indeed. But it will be more efficient if we don't have the tunnel. We don't need the tunnel at all, right? So another aspect was brought up by in the email discussion is about multicast. How do we do multicast? Why would multicast be easier? So again, consider that now the NUP is a router switch with wireless connections to the UEs and a wired connection to the data networks. Then when it comes to multicast, the downlink multicast traffic will arrive at on the NUP itself using the whatever multicast means you do in your data network. Because in data network, which is basically the VPN or whatever, today we have multicast solutions. Whatever is available there, you can use it to get the multicast traffic to the NUP. Once you get to the NUP, and then the NUP will use radio technologies, whether it's P2P radio bearer or P2MPP radio bearer to get to the final UEs. And that's 3GPP technology. But you can see that basically we're reusing the wireline technology to get the packet to the NUP. And then from NUP to the UE, it's the last step is simple. Similarly, for uplink traffic, the UE traffic arrives NUP, and then it continues to other NUP or to the data network side by whatever multicast solutions you have for the data network. So it should be much simpler here. Next slide. A big question here is QoS. What about QoS? So I have this picture here on the right side, at the UE at the bottom, and the integrated NUP device in the middle, and then I have a data network router, more like a hub router at the top. So the QoS between the NUP and the UE, to me, is just still like the old days between the CE or CU device and UE. That does not change. Previously, when you have the co-located CU and the UPF, there is a very short connection, even internal link. There, the QoS should be very trivial. There's not much QoS to be done there. And now, once you have the integrated, it's just gone, not needed at all. And then previously, when you have UPF and the CU separate far apart, and then you have N3 tunnel, yes, there are some QoS related to the N3 tunnel, but the N3 tunnel is going over a transport network. that cost need to be realized through the transport network anyway. And now when you have the NF being there, then that part of the cost, instead of being the N3 cost over a transport network, it just becomes the data network cost over the same transport network. So it's pretty much still the same thing. And now I have to say that myself don't know a lot of details on the 3GPP side, but what I imagine is that with the integrated NF, there is some signaling coming to the NF telling the cost parameters for PDU session. And those signal cost parameters will be used to control the cost between the NF and UE. And it also can be used to control the cost between the DN router and NF. For example, when that NF advertise routes into the data network, it can carry some cost information that is gathered from the signaling to the NF. And then that way, the downlink traffic from the DN router will be subject to the cost when the traffic leaves the data network router. And when it goes through the data network, it is through that whatever cost marking, it can be handled accordingly.
Yeah, Luigi, one comment. I mean, if you're mapping QCI to DSCP hypothetically, just using just one example, it's normally done at the N3 interface CU, just GTP. But if you remove the GTP tunnel, now you're dependent on the packet toss. So there's going to do you still need mapping? Maybe you don't. Maybe you just let it, if it's best effort traffic, it goes. But if you want a specific treatment to it, you'll have to do the mapping before or maybe the MUP does the mapping. But some QCI to DSCP, depending on the use case, if it doesn't need to be mapped, then you carry the packet toss. If you do need it to be mapped, then you got to figure out where to do that part to make this fit within the overall picture.
Right. The key point is that it's nothing that you cannot do. Whatever you can do before, you can still do it with this model. Yeah. Next. Okay. So the discussion also talked about network sharing and the intermediate UPF or intermediate SMF. So I pointed out that there are cases where you still need to have separate the AN and UPF. This included home router roaming, virtual operators, and in just some cases, you need to have 1-to-N ratio for the UPF to an AN. For example, you do not want to run a UPF for every of your CU device. You just want to have one UPF for a bunch of CU that are close by. For whatever reason, you may need that. In that case, we can still separate them. So basically, you integrate them when you can, and you separate them when you have to. So now with that, when you do the integration, the intermediate UPF will no longer be needed, and accordingly, you don't need the intermediate SMF either. Without integration, then the intermediate UPF, intermediate SMF can still be used as before. So, so basically, this is just a summarize of the discussion on the mailing list, and in particular, my responses to those raised questions. So I really appreciate these comments. I want to see this discussion keep going, and also I'll ask people in this room if you could discuss this idea with your wireless colleagues to see if this makes sense. From my point of view as a IETF person and wireline person, I think this makes sense, but we need to convince people. Maybe I will get rejected, but at least if we can have this discussion, that would be great. And also, I want to point out in the 0.1 revision, I covered some points that John and Hanno brought up, and there are some points I didn't get to add them, but I will add them.
Okay.
Thank you, Jeffrey. There's one comment from Marco Levish. Is this only about collapsing N3, but there will still be a session anchor for mobility management over N9? Or is it about moving mobility management to N6, since N3 and 9 will disappear? For the later case, there were a couple of drafts in the past. There was one from Marco Levish. Yeah.
Okay, so we still have anchoring point here. It's basically the NUP here. NUP is a combined CU and UPF function. UPF is the anchoring point. So,
Understand? Okay, thank you. I think you said it right. This is a completely 3GPP specific thing. I don't have to say much further on this because we are not chartered to work on this.
Right.
Right, Eric?
But I appreciate this
Yes,
venue.
if I touch on it, I get a lot of pressure. So.
Yeah, right. I do appreciate to have this opportunity here to socialize the idea.
That's good.
Yeah.
That's fine. I think we have time, no problem accommodating you. But as long as if it's IETF, if you can do something to do something,
Yeah.
That's fine. But you cannot go and say,
Understand. Yeah.
ridiculous.
Yeah. Okay.
All right. Thank
Yep.
you, Jeffrey. If there are any, that's it. Right? So that was the last presentation. So if there are no other comments, we end the meeting and hopefully see in IETF114. But definitely, I actually definitely. He was not active, but even Suresh put the third year because he completely disappeared for 2 years. So it was implied that he was not, but he was officially listed. Technically,
Yes, we have the marks are very difficult. So I see how I like to. I would like to please for refreshing the expression to all this caption. So I will see the recording for refreshing.
because the rules change. Nobody knows that.
I had a very
The DP
and I
isolation.
was hinting at, he said that he was telling me that why he thought Joel was wrong about impacting the GR. His statement was